video. This is Control, and today is day 36. So we've been streaming for about 36 day for the new ones. This is Control, and we solve lead code problems every day until I get a internship or a job. This is Control. You can find me on GitHub, or you can find my social media account in the bio of the YouTube channel. This is my LinkedIn, this is my GitHub, this is my Instagram. And recently we did a server Discord. You are all free to join it anytime you want. So today I'm gonna solve some lead code problems about the backtracking. So this is the theme of yesterday. So the theme of today is about My Hero Academia. It's a known anime. So where is the theme? Okay, so this is the theme. We have two lead code problems. The first is data combinations of a phone number. So use a training simulator to unlock combined quirk abilities for maximum effectiveness in a rescue mission. And the second one is combination sum 3, which are two medium lead code problems. Hope you all doing good, and without further ado, let's go to the lead code problems. So let's bring our whiteboard, no, something like this, and let's go. Okay, so like I said, yesterday we did the binary search problems, and today we're gonna do some backtracking problems, which are interesting and really interesting design pattern to work on it. So this problem is about a given string containing digits from 2 to 9 inclusive. Return all possible letter combination that the number. Oh, and by the way, here we have the permutation and we have the backtracking algorithm to help us solve the problems. So hey, welcome man, welcome stream man. Hey, thank you man. Welcome. So possible letter combination number could represent, return the answer in any order. Okay. A mapping of digit to letter, just like the telephone button. It gives below, not that one does not map to any letter. Okay. So 1, 2, 3. Digit 2, 3. The output is AD. Okay, so 2, 3. Oh, AD, and then AE, and then AF. And if it's only one, so we're gonna print this. Okay, so like I said, we are working on backtracking algorithm, which is pretty interesting, yet it's not the hard. And we're gonna have the example of like numbers. So if we have 1, 2, 3, and we want to print or to know all the combinations or the permutation of this number, which is a at any time, or we have to print a number of 3 integers and we have to permutate those. So the possibilities are gonna show up in a tree. So in every time we're gonna start with a number. So here we can either start with 1 or with 2 or with 3, and for this number 1 it's got to have the rest is 2 number, which are either 2 or 3. So here it's 1 and here is 2, so it's 1, 2, and here is 3, so 1, 3, and there is only one number left. For this it's 1, 2, 3, and for that is 1, 3, and 2. Same thing with this. So here it's 1 and here 3, so 2, 1, 3, and here 2, 3. Oh no, 2, 1, and here 2, 3, and that it's only one number, so it is 2 3 1. So on every time we're gonna choose a number, and then we're gonna go back like v2. We're gonna go back to the 1, so we add 3, and then we go back to this, we go to 2, print all the possibilities, and then we go back to 3. So there's a really simple pattern. And for now we have a problem that is similar to this. So let's just write the algorithm of the permutation of the number, and then we're gonna apply it to this problem. Okay, so let's begin. So for this we're gonna need two lists, which are we're gonna call it like res and solution. Okay, so we're gonna make it like this. These are two empty arrays, and I'm gonna make vlen. So one thing, if we have like 2 digits, the possibilities will be 2, and if we have none, the possibilities will be none, the length of every possibility. And if we have only 1 digit, every possibility will have the length 1. So the number of digits will get us to the number of length of the possibilities, and the possibilities here are the number of digits factorial. So if we have like 2 3, so they are 2 numbers, so the number is number of factorial. Oh no, it's not 2 factorial, it's 9. Okay, so here it is 1. Well, in this problem it is factorial. So if we have 3 problems, so the factorial will be 3. So we have 6 answers, and for that I think it is 2 factorial multiplied by 3, because so now it is because 3 letters, so I think that, so 3 letters and 2, so I have 9. No, like I said, in this is is a number of it, and then okay, we're gonna make it n equal n of digits, as I said, which is gonna be 2, and then we'll have a we're gonna define our backtrack function. Let's put it without parameters, and then we're gonna know what to put into it. So now, so yeah, after completing a like path into this, we have to add this number to the list, to the final list. So if the len of the 2, like the length of this is 3 and this is 3, so we're gonna make a condition to put every possibility in the final list, which is if length of the digit equal the length of the combined letters. Hey buddy, are you on LinkedIn? Yeah, I am on LinkedIn. Lead code contest rating. Well, I think well this is my profile. For the LinkedIn thing, yeah, I am on LinkedIn. You're gonna find all my social media account on YouTube bio. Welcome. So I don't really know where is the ranking. If you are talking about this, yeah, I'm not the professional, you know. And from the beginning of the series, which is a month ago, we solved about 73 lead codes. So this is my first time solving this number of lead codes problem. and you're very welcome to stream. So we're gonna start. So if length of the solution, which is a temporary list, we're gonna put into it the numbers equal n. So we're gonna add that to the solution, to the res. So res. Oh good, you still haven't given any contest. Yeah, I think. I really don't have much of time to do like it. I'm really I have like school, uni, and some project to do aside. So yeah, and if the chat want, I'll try it. So I think we're gonna add to the list the combined. So I think we're gonna make the join. We're gonna use the join. The join solve the solution. Okay, so this is the one. And simply but return. Okay, and if it's not, so now we're gonna add. Okay, so now we're gonna add. So we're gonna iterate through the digit. Oh, we have to make a heap. Okay, to make every like integer correspond to this. Okay, so like I'm gonna call it hash1. So hash1 equal. I'm just gonna. So is there already hash? So A, B, C, and then okay. So let's repeat that. How about 1, 2, 3, 4, 5, 6, 7? Okay. We're gonna repeat that for 7 times. Okay, so here we have 3 DEF 5 this GQL and 6 this MMO. Okay, so 3 times 3. Okay, so 7 will be PQS. 8 will be TUV. Send me LinkedIn connection, buddy. I'm having trouble sending. Is that your name? Okay, I'm gonna search it. Okay. That's cool. So, Darson. I think I found you. Okay. So I think it's good. I sent you a connect request. So 8 TUV and 9 is XYZ. Okay, so we're gonna iterate through this hash. So we're gonna iterate through the digit. So for GN, or like we're gonna make a digit for digits and digits. If digits, it's not already in the solution. So if here we're gonna input 3, so if 3 is not already in the solution, we have to add it. So if digit, oh no, for digits and digits we have to map it. So it's not in digits. For I'm currently 21, landed a job 6 months back, hey, congratulations, man, congratulations, I'm so happy for you, yeah. In which company? Astra Security. Hey, congrats, bro. Very happy for you. By the way, I'll be so grateful if you talk it for them with me, like with them for me. I'll be so happy, man. So okay. Now we're gonna map through the digits, or we're gonna make we have to make a variable. Okay, so it's gonna be good. I think we have to make a variable, so I'm gonna make it num equal digits, yeah, digits of okay, so when then we're gonna call the function, so backtrack, we have to call on the first number. Okay, so I'm gonna make it 0. So I have to make a parameter here, which is like e, and then nums will be the digits of the u, which is the number 1. And here, if digits in nums, in hash1 frames, hash1 of we Golang in our tech stack. Oh, yeah, unfortunately I don't really know Golang, but yeah, I'll practice it. Like in my country, Tunisia, they don't use it. It's very unfortunate. So hash1 of nums, num. Let's make it num. If digit not in solution, then we're gonna append it to the solution. So rest dot also so dot append append digit, and then we're gonna use the backtrack to make it recursive. So backtrack I plus 1, and then we're gonna pop to return to the second one. So sol dot pop. Okay. I think that's good. So backtrack 0, and then we return the rest, the final one. Hmm. Okay. Hey yo, it's 90 minutes. Oh, so we have. Oh, so we have to make this. Okay, so what do you do? So so if n equals 0, so there is nothing, then return. What's we gonna return? Empty list. Hey, yo, it's 19 minutes and we're good. Okay, so let's submit it. Hmm. Oh, so we can. So we can. We can repeat the same letter. Yeah, we can. Um, props to you, bros. I started college not so long ago, and I also started to see your life. Hey, thank you, man. Hey, welcome stream, man. Welcome. You're very welcome, man. So you are since day one. Hey, very appreciate the help. Very appreciate all the support. Thank you, man. Thank you. Hope you're doing good in your studies. Hope you're doing good in everything, man. Okay, so there's problem here when we repeat the same digit. So the second. Oh, okay. So the second digit is not considered. A B A C B A B C C A C B. Okay. Okay, so let's test it. If n backtrack equal n append join for digit in hash one app if digit not in sol. Sol append digit I plus one sol pop backtrack 0. So I think the thing is here. Okay. Or he is not appending. No, that's good. So I think the thing is here. Oh, okay. So let's just get rid of this condition and let's see. Okay, we're cool. Okay. Oh, it's 23 minutes. 3 minutes, yeah? Oh, we're doing progress, man. Making it good, man. Yeah, it's very good. And the complete, it should be n factorial 3n multiplied by 4m. What is the n and the m? 4. Oh, okay, so this the n, I think, and the number of repetition of this is m. Yeah. Oh no, so this is m. Oh, yeah, okay. So this is m and I don't know. Hmm. Okay, so I think this problem is good. Now let's go back to the other one, which is combination sum. So as I said, the backtracking is not that hard. You just have to understand it. And the previous problem was very similar to permutation number, which I already done it in like last year. So I remember it, but this we have to make it over again. Okay, so let's go. Find avoid combinations of k numbers that sum up to n such that one following condition are true. Huh. Okay, find avoid combination of k numbers that sum up to n such only number 1 through 9 are used. Okay, each number is used at most once. Return a list of all possible valid combinations. The list must not contain the same combination twice. And the combinations may be returned in any order. Okay, so k3 and n equals 7, 1, 2. Okay, so 1, 2, 4. So this has to be the result of the sum, and this has to be the number of integer used. There are no other valid combination. Okay, so 1, 2, 6, 3, 9, 1, 2, 6, 1, 3, 5. Okay. Okay, so let's draw. Okay, so we have k as an input, k equal 3 and 9 equal n equal 9. 3. So the 3 will be the number of this list. So the output will be a list of list. This is k. This has to be k. And n has to be sum of this. So sum of this has to be n. Okay. And number are used are from 1 to 9. Okay. And the number in every list, in every this little list, has to show only one time. Okay. So we're gonna use the if. So we're gonna use the condition not in. Okay. But what are we gonna iterate through? So we have to know what are the choices. So what is the thing we're gonna Okay, so if we have n equal like 9, so all the integers have to be less than 9. So if n equal 7, we're gonna have all the integers from, is 0 considered? Oh no, 1. So we're gonna use 1 to 6. We're not gonna find like bigger integers or greater integers. So it's from 1 to 6. Okay. And it has to be composed of 3 like nums. Okay. So if we choose 1, this is 1. What is the 3? We have all the other possibilities. Oh, okay, so 2, 3, 4, 5, 6. If it's 1 plus 2, so it is 2. And okay, so the number, so either 1 and 2 should not appear again. So this will be either 3 or 4 or 5 or 6, and the sum has to be 7. Okay, so 1 plus 2 is 3, so this has to be 4. And this 1 and 3, so 4. And this is 3. 1 plus 4, it's 5, and this has to be 2. and this one plus 5 is 6. It says, oh, so in that case, when we cannot choose one because the number 1 must not repeat, and this 1 plus 6, it's not valid because we have to choose another number. Okay. Uh, okay. Okay, so let's draw it. So let's choose k equal 3 and n equal 7. There's only one valid combination. Okay, so let's start from, we have 1, 2, 3, 4, 5, and 6. Okay, so this is 1, and then we'll have to, there is 3 here, so either 2 or 3 or 4 or 5 or 6, and then we cannot choose 1, we cannot choose 2, we can choose from 3 or 4. So what are we gonna choose from? Okay, so we're gonna take this n and we're gonna iterate through a list that is from 1 to n, or less. We can choose 8. But every solution, so I'm gonna make for e lower than k, because every list has to be composed of 3 elements. Okay, so let's begin the structural things. So I'm gonna make a lists and solutions, and that will be okay, what does the algorithm set? And like I said, this is the algorithm of the backtracking on a permutation problem, so I think we're gonna need something like this. So okay, we don't really actually, okay, so let's begin to define backtracking. So our condition, if length of the solution equal to k, then we're gonna append to the rest the solution, then we're gonna simply return. Okay, and now we have to define the logic. Okay, so how I'm gonna so I think I have to create a list which is nums. I'm gonna call it nums. It is a list of in range n. I think that. Okay. So I'm gonna print the nums to check it, and then okay, so now I'm gonna iterate through this. Hey, hello man, web dev or something. Now we are doing some lead code problems about the backtracking pattern, and yeah, I'm doing some lead code. So and I'll try to include some projects in the upcoming videos. So follow our YouTube channel to catch to catch the news. You know. So now I think I'm gonna iterate through the num. So for num in nums, and then we cannot repeat the same thing. So if nums not in solution, we're gonna append it to the solution. But we have another condition. If solution k and sum of the solution equal n. Okay. We're gonna append it. So solution dot append. Okay, so it's no. And then solution dot pop. Okay, so I think this is good. Like, we're gonna define this and return this. Okay, so let's see. Okay, at least there is no error. So the case 3 is good. The nums are good. 0, 1, 2, 3. Okay. I just want to print. Oof. Why is he outputting a... Okay, even the number of the list is not... Okay, so let's see it. If len of solution equal k, and sum of the solution equal n. I'm gonna append the solution. So for num in nums. Okay, so I'm gonna iterate through this. If num not in solution, actually I think this is not num. Are we gonna make a nested loop? This has to be like 3 times. So for like for g in range or while I'm gonna repeat 3 times. So for g in range. Okay. I think now we have to pass it as a parameter. So if okay, I'm gonna do it like the previous one, like we did here. Okay, so num equal nums of I. If num is not in so, and here I plus I, here I, and here 0. This should work. It's like the previous one. List index out of range. I really don't know what is going on. Right. So okay, so we're gonna test it. So backtrack of 0 is gonna make nums equal nums of 0, okay. And then for g in range k, so it's gonna repeat it 3 times. If num is not in so it doesn't not in so, it's gonna append it. Then he's gonna backtrack plus 1. Then he's gonna repeat the process. What is not working? No, actually, I'm solving it by data structure. So in this 75 lead code, it is divided by or categorized by data structure. So we solve with 2 pointers, sliding windows, DFS, BFS, binary tree, DFS, graph, heap, binary search, and now we are solving the backtracking lead code pattern or patterns by patterns and by data structures. Welcome stream, by the way. Okay, so there is problem with the range of this. So if I'm gonna no, I cannot. I don't think this can work, but same thing. So okay. So okay. So when he, okay. Uh, okay. So if I equal n minus one, then I'm gonna simply continue. I'm second to. Hey, I advise you with this lead code pattern. Lead code like patterns video. This guy is so good with it. So just lead code 515 patterns. This demonstrate very well the lead code patterns or the problem solving patterns. He's really good with it. So watch it, and I think here there is the point 2 pointers. Yeah, I think this is it. So watch it and solve some. Hey, thank you, man. Love. Hey, thank you, man. Welcome stream. Okay, so uh, okay, so why it is? Oh, you already seen it. No, it's not the hard. The pointers. It's also an Indian guy when it comes. Yeah, they are very smart, man. Yeah. So I don't know why. If I equal. Okay, so in every time I have to print. So print I. Okay, so 1, 2, 3, 6, and then 6. Hmm. So there is a problem with the last with the last. Okay, so when you have to go to the other one. So if it's well, it is empty, man. Okay, so I'm gonna try to print the solution. Hey, best of luck, man. I'm from India. Hey, nice to meet you. Okay, so 0, 1, 2, 3, 5, 5, 5. 0, 1, 2, 3, 4, 5. What is going on? Hmm. Can I make pass? No, not pass. Hmm. If it's the last number. Like why in this problem it is going all good? So it's digits and then I plus 1. Sorry, man. Why it is all good for this thing? Why there is no so if it's digits of digit of 2. Oh, because it is a Okay, I see. Okay. So don't really know why. So he's not adding anything to the rest. Why is that? Sound difficult with JavaScript? I think it's not a bad idea. Well, the most languages that has the faster runtime are C++ and Java, and I think JavaScript is not bad. It's not bad at all, and you learn how to work with JavaScript on other projects. So I think it's a good idea. Okay, so what is this thing? I think there is a. Okay. So and like make it like this and see. Oh, no, I think that's not gonna work. Okay, so I have to append. So I think this 4 is not. Or the nums of I is not. Mm, we have to make a permutation of 3 numbers. We're gonna append 3 times. So let's think about another time. I have 1, 2, 3, 4, 5, 6, 6, and then we have 2, 3 until 6. Same thing. Oh, but 1. and then we have like here we have 3. So we're gonna append in it 3 times. So it is composed of 3 times. So 4 digit in hash map of nums. 3. So this has to be a 4G in range K. Yeah, it is 3. It's all good. We add 1 and then we add 2 and then we add 3 and it's gonna add until okay, for nums not a soul and soul. And soul and limb of soul is lower than 3 or than K. Oh god, I don't know what is going on. Is there any hint? Can we use 9 loops? Okay, so it's now like 30 minutes. I think I'm gonna see the solution. Okay, let self DFS list range 1 to 10 K and let. Okay, so if K and then return path in range to path. Just amazing. Use thing. Red to the band path. And where is the path? So self DFS num plus 1, this is recursive, K minus 1, and n minus nums of I. And nums, what is nums? Oh, the nums, it's the... No, it is not. Okay, so nums here, it's range 10 1. N minus nums, path plus sum. Okay, I have to understand this. I'm gonna وين تقرا خويا اي تي شو اسمه. انا عملت دوزون بريباراتوار بعد ما عطونيش الشوا نحبو دونك جي مشيت للاي تي اللي هي يونيفرسيتي بريفي في صفاقس. انا نسكن صفاقس دونك نقرا دوزيام اني جيني انفورماتيك. مرحبا بيك في ستريم بابا. Okay, so the code defines solution method in combination. Initialize the empty red called the depth of search. So this is the backtracking function, an empty path, and the result is return list contain all valid combination helper function DFS base case 1 if k too many numbers or n some exceeded. Oh, so stop exploring this path. Okay. بورتفوليو اي بالطبيعة. تو تلقى الجيت هاب نتاعي في اللينكدين في اليوتيوب بايو. دونك ديجا في وسط بروجيات منهم واحد بورتفوليو مي قديم الحق مازلت ما جدتوش. دونك تو تلقى الجيت هاب نتاعي في اليوتيوب بايو. تنجم تلقى اللينكدين كان تحب كونكتي معايا على لينكدين تلقى كل شيء غادي. Okay, so here too many numbers and some exceed. Okay, so if k equal add the current path to it because it's form a valid combination. So I didn't really. So it is k. K red dot append. So for e, so this is the loop for e in range len nums, like I did. K. Oh, len nums, which is k. K, it's. Oh, no, not k. It's the range of this. Nums, yeah, nums. Oh, so this is nums. Nums plus 1 is gonna go through the rest of the list. K minus 1, he's gonna increase it. Oh, he's gonna increase k until the it gets 0, so it is composed of k elements. And 9 minus nums of. Okay, so he's gonna make it the other way, like he's gonna make it in descending way. Path plus he's gonna add it every time to the path, and then he's gonna make all this in the red. Okay, dot. So if he has the valid combination, he's gonna add it to the red, like this. We're gonna add it to the rest. Yeah, clever. Yeah. This goes so good actually. Okay, so let's just test it. Oh good. So شو نقدر نسمع فيك وانا نجراندي في الكوتا كول تنام ضلها وادي. شو نقدر نسمع فيك. مرحبا بابا، مرحبا بالطبيعة. Unexpected incident. Oh, okay. So self and then return. Return. لازم return هنا. Okay, so this is good. It's really a good method. Let's just make it into smaller parts, like he did the other way. So this is how I got it. Okay, so let's it and make this. Okay, so we have a empty list, initialized empty list, which is a ret, which is the final one he's gonna return. Okay, and then this is the DFS, which is the backtracking function. He's gonna make it recursively, so he initialized a list range 1 to 10. So the first one, he made this function, and this is a list from 1 to 10. And then the other parameter is k, and then it's an empty list, and the ret, which is the final function. Okay, so now let's just explain this for loop. So the for loop for a range len of nums. The nums here in the first it's 1 to 10. So he's gonna go now from 1 to 10. He's gonna make a self DFS, is gonna backtrack in it, he's gonna make it recursive, self DFS, nums of I plus 1 until the end. So he's gonna, now he's gonna iterate not from 1, so he's gonna go from 2 until he reaches 10. And for every time he's gonna decrease the k until he go like, where is the description, until he like have only 3 integers in every list. Can you explain what deadlock is between two threads? Oh, actually saw it. Can you explain what's the deadlock between two threads? Like when two threads are working in like simultaneously, or are like not simultaneously, but are sharing the same thing that they are not supposed to share. I think that I'm studying parallel programming, so I think I know this. Maybe I know it in French, but in like deadlock thread, I'm really not familiar with it in English. Okay, so and n, so he's gonna also decrease n from nums I. So if it's 9, oh, okay, so if it's 9 he's gonna decrease 1, so it is 8. And he's gonna decrease the other one, like 2, it's gonna have 6. And decrease the 3, then it's gonna be 3. Oh, so so to have the valid combination, this number has to be 0, because like 1 plus 2 plus 3 is not n, so it has to be n. And path plus number of I, which is the temporary list, and then he's gonna append the path to the ret. Interblockers, they are both trying to access the same registry. yeah donc عندهم كيما نقولوا شو اسمه الأخرى variable partagé ولا ريجيستر ولا فازة، يحبوا الزوز معناتها يدخلوا لها فرد وقت. جوست الفوكابولير مانيش مستانس بيه بالانجلي برا. Okay, so I guess deadlock show up due to race conditions. Okay, so and then this is the like a break case. So if k equal 0, he's gonna decrease every time k. If k equals 0 and n equals 0, then we have our valid combination. Then he's gonna append it to ret. And after all this, he's gonna simply return ret. So it is another approach actually. So the most used approach in the backtracking is the one we used it in the letter combination. For example, if you have like 3 or like 4 integers and you have to print all the possible combination of it, you can use this as a solution. So you initialize 2 lists, which is the final one and the temporary one. You you make the length of the of your parameter of your choice in a variable, and then this in each case, and then you go to the backtracking. Use Microsoft Whiteboard, it's better. Microsoft Whiteboard. It isn't this? Okay. Whiteboard. Can I like say it here? Whiteboard. Oh, so I have to like download it. I'm really fine with Illustrator, so we're gonna continue it until we go to the Microsoft Whiteboard. So, and then this the final like condition. If I have a valid combination that's composed of n integer, then I'm gonna append it to the final list. And this is our logic. So for digit and hash map n1, or for digit and digits. So every time we're gonna append the digit. In this case, we have to add the condition if the number is not already in the list. And then we're gonna make our recursive thing and then pop the thing, because we have to return, like I said, we have to return from 2 to 1. So it's pretty simple. It's an interesting algorithm. I think tomorrow also we're gonna train on it. So stay tuned, and I think this is the end of stream. Thank you everyone. This was a really good stream. Thank you for interacting. Thank you for following. If you are not, if you didn't subscribe yet, what do you wait for? Do you know the case CS problem set? No, I actually don't. Problem set. Okay. Oh, this is looking good, man. This look good, actually. Okay, so what is this? Sorting, searching, solution. Shall I try this one? So this is the end of stream. Like I said, thank you everyone. Don't forget to follow this channel, this YouTube channel. Don't forget to follow me on my social media account. You can find them on the YouTube channel bio. Thank you everyone. I'm really happy to connect with you, to talk with you, to interact with you. Welcome everyone, and see you tonight. And see you tomorrow. Actually, good night.